Hello, Music Theory 4. We are moving on to Chapter 37, which is very similar to Chapter 36. Chapter 36 is a little bit of an introduction, getting used to things. And Chapter 37, we're actually going to breeze through with probably just one lecture on this before moving into a brief summary of serialism. We'll probably do one matrix if you were ever excited about doing that type of stuff. We're going to breeze through the rest of the couple chapters here very, very quickly, just to kind of touch on different things. We'll organize ourselves before the end, and then prepare you well for this final exam that we'll have online. But for now, let's keep on going with set theory for a little bit. We're going to do the last step in set theory. Well, one of the last steps. If you want to go deeper into this, you obviously can. But we are in this class. We're trying to introduce you to a lot of different things all at once, and we'll have a nice review of everything. Don't worry, before we get to our final. So, set theory. So far, we have learned integer notation, where we say, hey, C, D, E, F, G, A, B, all those letter names is just from the diatonic scale. They don't really mean anything necessarily. We can call them scale degree 1, 2, 3, 4, 5, 6, 7, and then transfer them between different pitches, different frequencies as well. And that's kind of where tonal theory comes in. But we call them A, B, C, D, E, F, G on the staff. That's mod 7, because then we go G, A, and the next A is the next octave. That's the idea. But integer notation gives us a word for every single sharp or flat and the normal keys. So what I want to do here is share my screen here and just kind of review all this stuff with you, because some of you are still kind of not confused about it, but you're getting things wrong, and it's easy to get some of these wrong. But I want to give you a couple tips and tricks as we go. We all know C is 0, but some of you say 1 often. Why? Because C is always 1 in diatonic mode C major. That's probably why the confusion comes in. But remember, all C's are considered a 0, right? That's 0. Okay. 1 becomes the first black key, C sharp or D flat, and 2 is the next. And that makes sense because it's 2 whole steps above. And this makes sense that would be 4 because it's 2 half steps above that, with the 3 being in the middle here, right? And that's a whole step as well, 1 to 3, 2 half steps in between. The 4 and 5 collection right here, that's part of the diatonic collection, and that's our fa mi, right? That's not the right. That's not the right pitch. That might have been, but fa mi re do, right? Fa mi. There's a tendency tone there. In the same way, over at 0, the 11 B, 11 or E, is a tendency tone upwards, right? And these tendency tones are actually kind of important, even in set theory. They're not explicitly important, but they're important because the listener hears them, whether or not you intend that. It's pretty cool. But don't worry about it for right now. We're just going to keep the math going, okay? Right here, 6 minus or 6 plus from this 0 to or that 0 is the tritone from C, right? That's 6. That's F sharp or G flat. 7 then would be our perfect fifth. 8 would be the A flat. 9 would be the A. And 10 would be the B flat, where 11 is here. Okay, that's how that works. Okay, we have a pentatonic scale or a minor pentatonic on 1, 3, 6, 8, 10. We have a diatonic scale on 0, 2, 4, 5, 7, 9, 11, back to 0. Okay, and sometimes it's a lot easier to see this as a clock. 0 is here, or 12, right? 12 equals 0, because this is 12, right? But that's also 0. These we're doing mod 12, where we're basically going, okay, well, after we get to 12, we can say the next octave but 0, right? The next octave but 0. That's the same as saying, oh, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it goes back to 0, but we have 10, right? And that's kind of where the tens place comes in. 1, 2, 3, 4, 5, 6, 7, 8, 9. oh, now we have 2 10s plus 0. 2 10s plus 0. That's kind of how that works in mod 10, right? That's how we do counting. That's how we do it in here as well. This is just saying 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 0, but the next octave. And we keep on going from there. Quick quiz. Let me give you a couple tricks actually here. 0, 3. I'm going to put 12 here because that's sometimes easier for clocks, right? 0, 3, 6, and 9. What does that equal? It actually equals something both in the circle of fifths and the circle of chromatics as well. Now, you'll see that 3 is E flat, right? So chromatics is 1, 2, 3. That's E flat. But E flat major is actually over here in the circle of fifths. And 9, which is A, is actually over here in the circle of fifths. Isn't that kind of cool? It's kind of a flip version if you just use these points. Now, what do these points spell? 0, 3, 6, 9. That is a half or a fully diminished 7 chord. 3 half steps up, 3 half steps up, 3 half steps up, or 3 half steps up, and 3 half steps up. That's where this kind of comes in, right? 3 half steps up. Each one of those, if you just add 3 a bunch of times, that'll form a fully diminished 7 chord. That's actually where the octatonic scale comes into play as well, right? You have 2 diminished scales stacked up on top of each other, right? So if I just review the octatonic scale, we have these 4 notes in one, and if we decide to do a whole step first before a half step, we'll have 2, and right before 6 is 5, because 2 plus 3 is 5. 5 plus 3 is 8, right before 9. 8 plus 3 is 11, right before 0, and that's your octatonic scale. Might be an easier way. That's the 0, 2 octatonic scale, or as our book likes to call it, the 2, 3 octatonic scale. Octatonic 2, 3. Yeah? If you use all of those numbers, okay? Oct. 2, 3, or oct. 0, 2. Which, there's 2 different terminologies to do the same thing. Okay. Fantastic. Let's delete that real quick because we're not necessarily talking about that yet. Okay? So what I like to say is 0, 3, 6, 9, C, E flat, F sharp, A. That's how I remembered it so often because the fully diminished was like ingrained in me, and that's what I like to do. Okay, another way of thinking about this is just knowing that 7 is your 5th and 5 is your 4th, and then you can count from there if you need to. Eventually, you will memorize these, yeah, and I want you to start memorizing these as well. There's only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's only 12 of them to memorize. Okay, so memorize integer notation because it's going to be a lot easier math-wise to handle all of this, okay? Instead of having to, you'll just have to convert once if you can stay within the integer notation. Okay, fantastic. So that's a quick review of all of that. Now, what we want to do as we move forward, we're going to start talking about something called prime form. And prime form has to do with bringing everything back to C. As in, what does this look like in C major? Not exactly that, but basically combining everything into a single, easily definable set. All of the transpositions of a set, all of the inversions of a set, we'll call them a set class. Just like we call all of these guys C, even though they're different octaves, we'll call all of one set a class. So let me, a set class instead, okay? Let me show you kind of what I'm talking about. If we have the set 0, 1, and 4, 0, 1, 4 is our set. Okay, 0, 1, 4. That can be transposed so that that this first note becomes F sharp, so that's a 6, and then go up a half step to 7, and then go up 1, 2, 3 half steps to 1, 2, 3 right here. Now I'm doing something that I haven't explained before, but if you'd like to just use a keyboard, just use a keyboard. You can obviously see how this is related to this, and we have a way of describing that. We've already done the math for it. Transpose T6. right? That's the idea, okay? Now, we did a T0I, right? Like an inversion, or T0I, and that just meant instead of going up 1, we're going to go down 1, and instead of going up 3, we're going to go down 3. So we're going to do 0, 11, that's down 1, and now we have to go down 3, 1, 2, 3, to 8. So 0, 11, 8. So 0, 11, 8, and what we decided is that's not normal order, because normal order is ascending instead, and we want the closest possible ascending that we can. Instead of 0, 11, 8, we'll actually say 8, 11, 0, because that's the closest possible ascending way of putting that, okay? So it's 8, 11, 0. Now that's the inversion of what was our original set, right? 0, 1, 4. This is the inversion. This is a T0I. And then we could transpose that to get a bunch of different things. Maybe this inversion, maybe that becomes not starting on A. Let's put it up here, starting on C sharp, right? So let's do that. So it's going to be 1, and then they go 1, 2, 3, up to 11, 1, 2, 3, up to 3 instead. Oh, that's not 3. 3 is in C major. This is actually 4. E flat is 3 instead. So this is 4. 1, 4, and 5. Okay, we just transposed what was 8, 11, 0 up to 1, 4, 5 instead. Okay, so we transposed, or we inverted and then transposed up 1, 2, 3, 4, 5. So 5 to get to 1, right? So this is T5I. Inverted and then transposed. That's an inverted and transposed set of the same thing. But all of these sets are related to each other, right? By inversion or by transposition. Oh, actually, we said we can't do this. This is inversion of the, or this is a transposed version of that. That's not actually normal order. Instead, we should say the normal order is 5. No, we can't do that. Hold up. What's going on here? 1, 4, 5. That is the normal order. Yeah, we already have switched it. That's why. Because we're ascending instead. 1, 4, 5 as our normal order here. Okay? Yeah, good. Okay. There is a relationship between all of these, though, right? And that relationship is all of them started here, 0, 1, 4, and we just did some mathematical equations, and they all are going to sound similar. Just like do, re, mi, sounds similar enough to do, re, mi, right? Even though that's a transposition. Or do, re, mi. All of them have this major quality, even though I'm transposing from different angles. Now I could have been out of tune a little bit, but you get the idea, right? Do, re, mi, 0, 2, 4 can be do, re, mi on F major. And what we're going to say is that the opposite is true too. The inversions are related in a way too. Instead of do, re, mi, do, te, le is also related. And that's just the mi, re, do, and A flat major, right? That's just a different way of describing kind of the same process. 3 notes that are that are whole steps apart from each other. Yeah? So they're all related. The idea of set class is that we want to have all of those relationships defined by one single thing. Because if you think about it philosophically here, or just think about it mathematically, all of these sets will have the exact same interval class vector. Let's do the interval class vector just really quickly. We'll just start with a 0, 1, 4. That's really easy. 0, 1, 4. What's the interval class vector of that? We have 0 to 1, which is a half step. That's interval class 1. And then 0 to 4 is interval class 4, so we'll put a 4 over here. And 1 to 3 is 3 half steps, so that's interval class 3. That's very easy. So 1, 1, 1, 3, and 1, 4. So we're going to say 1, 0, because there's no interval class 2s. That's a 1 half step, yeah. And then 1 interval class 3 here. 1, 2, 3, 4, right? Oh, wait, I'm actually off. That's 1 half step. This is a 3 half step. Yeah, there's 0 2s, right? That's the idea. We're 1 3 and 1 4, 0 5s and 0 6s. You remember this interval class vector? And that is our interval class vector for this guy. I don't remember actually. I think you put them in parentheses. We'll have to look at the format later for the interval class vector. I'm just going to put I, C, V, where we determine all of the intervals together. Okay, that's 1 0 1 1, or sorry, all of the interval classes together. 1 0 1 1 0 0. Let's just double check real quick. We'll do an inversion of the same. We'll do 8 11 0. Oh, actually, let's do this transposed version even. 1 to 4 to 5, okay? So let's do that. So from 1 to 4, there's a 3. So 1 3. From 1 to 5 is a 4, 1 4. And then from 4 to 5 is a 1. Or is a 1 instead, right? So there's a 1 here. Guess what? Same. 1 3 4. You get the idea? It's the same exact interval class vector. All of these will be the same exact interval class vector because they have the same intervallic relationship. And that makes sense. So, all sets inverted or transposed with one another, all sets that have the same everything except that they've just been transposed or inverted, will always have the interval class vector. Therefore, they will always be part of the same set class. We're going to call this a set class, and we're going to have a parent class or a prime form for this class. That will be the most simple form of this class. And specifically, I chose this one because this is a prime form or a set class. We'll call it a prime form of a set class. And we'll explain why it's this one. 0 is just where we'll start. It really easily shows you interval classes or the interval class vector without having much work to do at all, right? So this one obviously says there's a 1 and a 4 because from 0 to 1 to 4, that they obviously have that, and then you just have to determine what this is, and you already know how many half steps, whole steps, minor thirds, major thirds, perfect fourths, and tritones, and the inversions of those that there are, right? So that's the idea. So 0 1 4 is a prime form that encompasses 8 11 0. It also encompasses 6 7 10. It also encompasses 1 4 5. They're all going to sound similar enough to each other is the idea. Okay? Just like do re mi or do re and re mi and mi fi and fi si, right? All of those are major seconds. They all kind of sound the same. They're just transposed versions of each other. Now we're doing it with a more complicated scenario with this 0 1 4 instead. Now let me do something real quick. I don't have a piano on me, but I do have my phone, and you guys can pull out your phone too if you'd like to and kind of play around with this. Listen to this real quick. That's an inversion starting on the 10th, on 10. Or that is more like it. The first thing that I played was slightly different. It wasn't 0 1 4, it was 0 1 5. Now that's 0 1 4. A 0 1 4 could be like this. I transpose that B flat, or the second note, up the octave before shifting back down to the 0 1 4. All of those was kind of improvising based on this 0 1 4 melodic motive, right? That's the idea. So everything kind of sounds in a similar vein, and that's what we can call a set class. Go ahead and take a picture of this if you'd like to. I'm going to stop share real quick to reset everything, and let's get into the book to see what we need to do to find prime form in the fastest way possible. and kind of explain what's going on here. Let's find here. All right. In this chapter, we group sets into set classes and learn how to recognize them. Recognize some of the most distinctive set classes in 20th century compositions. Okay, let's look real quick at the homework that we'll have to do. We have 37.1, both pages, 37.2A only. 37.1 is a bunch of exercises basically doing what we were just doing and having some reference points along with those. You know what? I'm going to go straight to the reference points because you can already do some of this homework, okay? Let me just kind of improvise a little bit more. Except to show you something, we're going to go into sets and set classes here. Set classes contains all the possible distinct transpositions of a pitch class set, as well as all distinct transpositions of its inversion. Pitch class sets in the same set class share the same interval class vector. Their shared intervallic structure gives them a similar sound. Here is the example from Bela Bartok, where these guys actually have the same prime form and they have the same pitch class set. Listen to it again. It kind of has this vibe to it, right? And that's kind of what we're going for. Okay, so instead of going through this, I will have another lecture that will go through the book explicitly for those of you who like that a little bit better. But for right now, I'm going to actually shift back to this glossary to Appendix 6, Set Class Table. This is page A88, it says. Hopefully that works for you. Okay. So the name here is what the set class is called. Okay, 3 represents how many pitches are per set, as in the pitch class set that has a prime form 0, 1, 2, as in C, C sharp, D, has the interval class of 2 half steps, which we can automatically see very easily, and 1 whole step, which we can also already see 0 to 2 is a whole step very easily. That's why prime form is so good to see. Even though a song doesn't have to start on prime form or anything like that, prime form makes it really easy to do math and be able to transpose very easily, and even be able to improvise if you want to introduce it into some of your improvisation techniques. Okay, so reminder: 3 means how many pitches there are. 1 is just a designation, and in general, you start with the most, or start with the lower number of. The lower numbers being the higher interval classes, and the later numbers being empty, right? You'll see as you go further in the 3s, everything kind of gets shifted over to the right here until you can't get any more over here, and introduce 4 instead. So this is the only, these 3s right here are the only available options for prime forms of 3 notes within an octave. And you can do the math yourself if you'd like to try to find another one if you can, but there's always going to be only these. Okay? So once you find out what prime form is, what the most simplified version of this pitch class set is, we have a name for it. It used to be called the fort name. We're going to call it the set class name now. Okay? That's a little bit, or fort number. Or a set class name is another name for that. Okay, it's just a designating system, and there's ways to read these that, like 3-1 may be related to 9-1 in some way. I won't give you that for sure what that relationship is, but you can see that just like 2-1-0-0-0-0 has a heavy emphasis on minor seconds, major seconds. This guy does too. Everything is built towards the front end. 9-1 and 3-1 has a relationship of some kind. For now, don't worry about it. Just be able to get to Appendix 6 to give the name, okay? All right, so what we're going to do here is I'm going to walk you through how to determine these by just kind of doing the first couple for you, yeah? I'm going to walk you through the first couple of on page 475 for you, okay, and then we'll be able to go from there. Good. All right, sounds good. So to walk you through this, let's start doing this real quick. What we'll do is I'm going to actually go to Dorico real quick so we can see all of this. If you look at the first one, we have G flat, E flat, D, G, and A flat. And they said the normal order was 2, 3, 6, 7, 8. Now, many of you would want to just say, oh, G flat is 6, and E flat is 3, and D is 2, and G is 7, and A flat is 8. And some of you would get that wrong even, right? But because you're not paying attention quite well enough, right? You can just create a cheat sheet for yourself until you get it, right? 0 is C, all of that stuff, right? 6 is F sharp. You got this, okay? All right, so those are the numbers, but instead of doing that, what we want to do is just circle them. Now, to the left right here, there's a bunch of scratch paper. So for B, we can just circle them right away. You can circle all of the notes that you have there, okay? So we'll do that in a second. But they said the normal order for this is not G flat, E flat, D, G, A flat, whatever those numbers are. When they circled them first, and then they determined, oh, there's a big gap between the 8 and the 2, and 2 ascending to 8. That's not as many as any of the other numbers, collecting all of them as they go around. Just ascending. So you have to start with 2. So the normal order is actually 2, 3, 6, 7, 8. Okay? 2, 3, 6, 7, 8. It says the prime form is 0, 1, 2, 5, 6. There are kind of 2 steps for this. Okay? There's 2 steps for this. For determining the prime form. We'll go over a couple different ways of doing that. The first step is to transpose the normal order to 0. Okay? So instead of doing 2, 3, 6, 7, 8, you want that normal order to go to 0 instead. Now, there is a little trick here that can save you some time, but we're going to do that for a second. To transpose that to 0, to transpose the first number to 0, you just have to go -2. That makes sense. That'll become 0, 1, 3. Or no, 0, 1, 4. 6 is not 4, right? They said 2, 3, 6, 7, 8 was the normal order, but then they said the prime form was 0, 1, 2, 5, 6, okay? So let me write these things down real quick so it's really easy for you to kind of see. I'm going to go for text here. We said, okay, so normal order is 2, 3, 6, 7, 8, and -2, T minus, or sorry, T 10 technically, but T -2 is an easy way to say it. The prime 4 then should be -2, 0, 1, 4, 5, 6, right? That should be the prime form, which is in brackets here. But they said their prime form was actually 0, 1, 2, 5, 6, and that is the technical prime form. Even though this will likely be in the reference book, let me check real quick for you. Let's go over here. Uh-oh, that's what we want to do. Let's check real quick. Let's go over here. 0, 1, 2. Yeah, they actually don't. Let's see if 0, 1, 4, 5, 6 is in here. 0, 1, 4, 5, 6. So we need 5 numbers, right? 5s. So 0, 1, 4, 5, 6. 0, 1, 4, 5, 8, not 5, 6. And we're out of 0, 1, 4s. 0, 1, 6, 8. 0, 1, 4, 5, 6. Interesting. If you don't find your prime form in this, it is not actually the prime form. You have to do an extra step to find the prime form. Okay, so you can check your answer very easily like that. 0, 1, 4, 5, 7 is here instead. Is 0, 1, 2, 5, 6 there? 0, 1, 2, 5, 6 right here. That is set class 5-6. And they put that down, 5-6. Okay? So how do you get from here, this answer, which was supposedly from the normal order, down to this answer instead? Okay? And I'm gonna help you out with this right now. Okay? To get from 0, 1, 4, 5, 6 to 0, 1, 2, 5, 6, we actually do the same. We look at this and we see that, look at this. If you go from the back end and go this way instead, the intervals will actually flip. Do the inversion of this, basically. How many does it take to get from 6 to 5? 1. So you're going to say 6 is 0 now. And then to get to 5, you go 1. To get to 4 from 5, you go 1 again, so add 1. And to get from 4 to 1, you go minus 3, so add 3 instead. 5. And to get to 0 from 1, you add 1. Or so you negative 1, so you add 1 instead. 0, 1, 2, 5, 6. That's exactly where they got it from. Now that might have been super confusing to some of you. And that is why we have a circle. 0, 1, 2, 3, 4, 5, 6. If you didn't understand it that way, I work this way really well. I just like that way, but it's not a bad thing to not work that way. It's just a different type of learning, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so what I'm going to do is show you an easier way to do this. We said this was the prime form, but it wasn't. We couldn't find the prime form from there. We went 0, 1, 4, 5, 6, right? 0 to 1 to 4 to 5 to 6. But if you look at this, the closer, and actually the normal order of this is not actually, it is 0, 1, 4, 5, 6 ascending, but descending works even better, right? So I want you to think 0, 1, 2, 4, 0, 1, 2, 0. What is this? Oh, I messed this up. Give me 1 second here. Let me redo this. I'm messing up my thinking here. 6, 5, 4, 1, 0. Okay, so I wanted to go backwards instead. 6, 5, 4, 1, 0. So if we consider this 0 and imagine us going backwards, now we're getting 0, 1, 2, and then we need to get to here, right? Because that would be where 5 is. 0, 1, 2, 3, 4, 5, right? But in the same way, 0, 1, 2, 5, 6, right? 0, 1, 2, 5, 6. We had to skip 1, 2, 3 to get to 5. So 1, 2, 3 to get to 1, which is actually 5, though. 0, 1, 2, 5, 6, because we're thinking about going backwards in time a little bit, right? Does that make sense? Okay, so the first way, I just did it by half steps. You can see the half steps are really close up here. So the prime form is better determined with the half steps closer to the beginning, or the smaller steps closer to the beginning. There's only 2 options. Once you have it in normal order, the normalized order, okay, go backwards or forwards to determine which one is the prime form once you transpose to 0. Now you can determine it right away by just looking at this and doing this first step first, okay? 2, 3, 6, 7, 8. But you notice that there's a bunch of half steps. 6, 7, 8 are right next to each other on the clock face. But if you can think in your mind, 8, 7, 6, 3, 2, interesting. That was our normal order, but this way has more half steps closer to the beginning. We're gonna, in our mind, think this is 0, and then to get to 7 we do 1, and then to get to 6 we do 1 more, which is 2, and then to get to 3 we do 3, so 2 plus 3 is 5, and then to get 1 more is 6. Okay, so you can work kind of in patterns that way if your mind is able to work that way. Okay, so just real quick, to determine prime form. 1, normal order. You gotta find normal order first. 2, transpose to 0, but not necessarily. Okay, you can skip this. You can skip this part. Transpose to 0. Check if prime form. Okay, check if that's prime form. If it is not prime form, in the back of the book, right? If you can't find the prime form, then it's not prime form. Okay, check back of the book. Okay, appendix 6. Okay, that's the idea. If not, invert, then transpose to 0 again. Okay, so there's an extra step if not. Now there's shortcuts, like I said, but that is going to be your guide. Okay, so write that down, get that in your head, and we will have another lecture on this later on. Okay, so let's do all of this stuff with our second option here. Okay, number B, or letter B, I guess. Yeah, so letter B here says here. What I'm gonna go? I'm gonna do this. I'm gonna say clock face for set theory. You ready? Clock face for set theory, images, and we're going to find one. Here it is. Oh, look at that. Look how cheaty we can get. This is perfect. Now, I don't want you necessarily using this all the time, but if now, you know what? I like you want to memorize them, right? This is a good reference point. Use the tools available to you. That's totally fine. Just you're going to want to memorize these eventually, right? Especially if you want to get into this for a long period of time. Okay. So what we're going to do is how do we get this? Let's try this real quick. Get this over, and I want to delete the rest of this stuff. Delete. Put this over here, and I also what I'm going to do. I'm going to save this here. Save. Oopsies. Save. Save to images, save to collections. What I'm going to do instead is just screenshot this. Screenshot it. Boom. And now we have a little copy that we can write on. Oh yeah, I'll just keep it like that, and we'll write on it like this. Okay? Now, let's go back to our book here. It says on 37B, or 37.1, 1B, first determine, for each given PC set, find the normal order and the prime form by one of the methods described in the chapter, and by one of the methods that I described here. Clock faces are provided for you if you choose them. You choose to use them, and that's pretty easy. You can do this. Fill in the SC or Fort number found in Appendix 6. So, we have E, G, D, F. Oh, very easily. E is 4, right? E is 4. Hey, look, they already have it for you. What is G? It's going to give you the answer. G is 7. Oh, D. D is 2. And F sharp is 6. Right? We got those 4. Now, to determine normal order, you have to go ascending, you have to go clockwise, and you have to start from the beginning here. And make sure everything's included. None of these guys are going to be included, so we're not going to use them. We're going to start on D and just go to here, and that's going to be our normal order. So to write your normal order then, let's type it in. D is 2, normal order with the brackets, 2, 4 for E, and 6, and 7. Now, there was one time that I actually said, no, we're not gonna go there. We're not gonna go there. 2, 4, 6, and 7. That's it. Yep. And guess what? I'm checking in the book right now. 2, 4, 6, 7. So if you're paying attention, that's good. Now I'm not gonna check in the book after this. No, I will for you. Okay. Now we said the second thing, determine normal order, transpose to 0. Okay, let's transpose to 0. Let's see what that is. And we're just going to do the math for now. We're going to say 0, because it's going to have to be 0 at the beginning anyway. 0 minus 2, or 2 minus 2 equals 0, so we're going to transpose down 2, or T10 it's called, right? T10 it's called, or you can say T minus 2. It doesn't matter too much, okay? Minus 2, so 0, 2, and 4, or 6 minus 2 is 4, and 7 minus 2 is 5. That could be our prime form. I'm going to put it like this, 0, 2, 5, or 4, and 5. Now, you can determine right now that this doesn't actually look like prime form because there's a half step right here between 5 and 4. But, just for kicks and giggles, we're going to check if it's prime form. So let's go back to our book, have this ready for you. I think mine's right here. There it is. We're going to check if it's prime form. We want 0, 2, 4, and 5. 0, 2, 4, 5 is going to be our attempt at prime form. So there's 4 numbers. So we're going to try to find 4 numbers that start with that have 0, 2, 4, 5. Oh, I'm seeing a lot of 0, 1s. 0, 2, 4, 5. 0, 2, 4, 5. 0, 2, 4, 6 is right there. But I don't see a 0, 2, 4, 5, and it was exactly like it determined. There's probably not a 0, 2, 4, 5. You got to look through it. But look, there's a half step between that 5 and that 4. So let's try to invert this thing. And we can invert and transpose at the same time if you're able to do the math. Okay? If you're able to do the math. So let's do this first, okay? So let's invert this first. So instead of 0, 2, 4, 5, which is going this way, 0, 2, 4, 5, we're going to go this way instead. So minus 2 to 10. Let's do this. Uh-oh. How do I get in here? Yeah, let's just do another one. Okay, so instead of 0, 2, 4, 5, we're going to try this. And so it's going to start with 0, and the inversion would be instead of 2, it's 10. And instead of 4, the opposite of 4 is 8. And instead of 5, it's 7, right? That's the inversion. But that's not in normal order. We actually have to flip that around, right? To actually make it normal order. We shouldn't do prime form here. 0, 2, or 7, 8, 10, 0 should be the for normal order, because we have to ascend, not descend, right? So instead, we're going to do 7, 8, 10, and 0, right? Now we got to transpose that to 0 again. How do we transpose it to 0? We can add 5, I guess, or minus 7. Let's minus 7. We're going to t minus 7 or t5, right? T5 is what we're going to do. T5, and this is T5i technically, right? We're going to transpose this to 0. So we're doing minus 7, right? Let's see. 8 minus 7 is 1. 10 minus 7 is 3. 12 minus 7 or 0 minus 7 or 0 plus 5 is 5. Okay, 0, 1, 3, 5. Let's check that and see if that is a prime form 0, 1, 3, 5. That looks better to me. Let's see what we got. Uh-oh. Not working? Guys, it's not working anymore. There it is. Okay. 0, 1, 3, 5. Let's see. Hey, right there. Oh, you see it? 0, 1, 3, 5 right here. This guy. 4, 11. 0, 1, 3, 5. I think that is probably our prime form. Guess what? I just checked our answer. 0, 1, 3, 5 is the correct answer for B, 37.1B. And then it says, write the SC number or the fort number, which is just right here. That's really easy. 411. It happens to have the interval class vector. You don't have to do the math anymore. 1, 2, 1, 1, 1, 0. Yeah? And really, really nice little set here. 0, 1, 3, 5. Let's play that and see what it sounds like. Nice. It actually is part of a scale. It's the ending part from so to do of a minor scale. 0, 1, 3, and 5. C, D flat, E flat, F is what I played. If C is so, then F would be do in that case. But we're not worried about that. We can transpose that however we want to, and all of those will be related in that case. Okay, that's the only one I'm going to give you. Number B, 2, 4, 6, 7. 0, 1, 3, 5, 4, 11 are your answers. You're going to finish this at C, D, E, and F. You're actually going to go to the next one, and you'll have to start from scratch for this one. You'll have to use Bela Bartok, these first 5 notes, and determine their prime form, doing all of those steps. So you might want to go back a couple and make sure you memorize those, or just look at your book. You'll have plenty of guidance there. And go throughout all of this melodic analysis and all of that stuff, okay? That you should be prepped to do all of that. And 37.2, just the first part of that instead, okay? There's a couple of big math problems, okay, to figure out. And at the very end, it's going to say the mode or scale that is associated or that is used throughout this entire thing. There's sets and a mode or scale that's used throughout this entire thing. And guess what? We talked about it earlier in this lecture. Okay, so that's a good hint for you. Do 37.1, 37.2. Hopefully this is fun puzzle stuff for you guys. We'll do probably one more assignment in this chapter before moving on to just a little bit of the next chapter with 12 tone rows and understanding all of that, and do some rhythm, meter, and form after 1945 to see what new things come up with that, and some more recent trends of mixing a bunch of different genres and all of that. Okay, that'll be our next couple lectures in the next couple weeks. This one is due on I think Monday night. You'll have the weekend to do that. It might be Tuesday night even. I might even give you more time to work on that, but that shouldn't be too difficult for you. If you have questions, reach out to me. We will see you next time. Bye.